Everybody for coming. Our next speaker is Rebecca Bilbro with Building a Gigaword Corpus, Lessons on Data Ingestion, Management, and Processing for NLP. Please give Rebecca a warm PyCon welcome.
Hello. Welcome to my talk on building a Gigaword Corpus for NLP. So I'd like to begin by talking a little bit about my motivation for building such a large custom corpus and for giving this talk. And I want to try to convince you also that you would like to build a custom corpus for text processing. But then I'm going to tell you all the stuff that could go wrong if you do. Just to kind of measure your expectations a little bit. So the kinds of things that will likely go wrong kind of from the beginning, the data ingestion phase, all the way through management and loading, pre-processing, and analysis. Then I will talk about some of the lessons that we learned. Hopefully you can learn from our mistakes and not make the same mistakes, make new mistakes. And also kind of introduce some of the open source tools that we built to make this work easier in the hopes that you will be able to leverage those tools yourself. First off, my name is Rebecca Bilbro. I am a data scientist. I live in Washington, D.C. I work for a company called ByteCubed that builds custom data solutions for commercial and government clients. But in my free time, I work on open source projects like Yellowbrick, which is a new open source Python library for visualizing machine learning model selection to support the modeling process. So it's pure Python, it uses matplotlib, and it's sort of modeled on the scikit-learn API, if you're familiar with that. So I do this work with a team called District Data Labs, some of which is here with me. And many of us are here at the conference, so you're likely to bump into some of us. So District Data Labs is a Washington, D.C. based open source collaborative. So it's a group of people who have day jobs but enjoy open source and programming and get together in their free time to build projects. And we try to support that by hosting research labs and development sprints and supplying things like pizza and water to encourage people from the community to come and develop with us. And we pay for those things by teaching classes in things like machine learning, natural language processing, data wrangling, distributed computing. And there has been recently quite a lot of interest in classes on natural language processing. And so this is kind of how this journey begins. There is a dramatic increase in recently in applications that are integrating sort of seamlessly and quietly, these innovative natural language processing features that extend the usability for all of us. So for instance, Gmail just released a new feature, probably some of you have noticed it, where it kind of scans through your incoming email and suggests, convenient, quick responses, so you don't have to type out like, sounds great, see you tomorrow. So this is sort of kind of happening in mass, and at the same time, there's this, flood of great tools in Python that we can use to build these kinds of applications. So when we started teaching classes on natural language processing, we started with these tools. And we started with NLTK in particular. NLTK, the Natural Language Toolkit, is an excellent library for kind of learning foundations of natural language processing. It comes with a lot of stuff, including things like part of speech tagging and lexing and custom corpus readers for all different kinds of corpora. And it also comes with sample texts that you can use to experiment and learn how this all works under the hood. So for example, it comes with books like Moby Dick. And these are texts that have already been processed, have already been part of speech tagged and parsed. So you can call really convenient methods and quickly kind of find word similarities and identify common contexts between words and look for the windows within which words are likely to appear, which starts to give you a really good sense of what's happening in the text. What it doesn't give you is a text that you can use to build like a whaling chatbot. So this isn't kind of sufficient. You can't just use Moby Dick to build something like that. You need a big corpus to do that. And so for something like that, there are big corpora out there that you can use. For instance, the Wikipedia corpus is pretty easy to pull down, and our friends over at GenSim, thank you, Lev, have made this a matter of just a couple of lines. They've got kind of these convenient tools, so you can pull down the corpus, you can quickly parse it and vectorize it and get it into a matrix and do something like latent semantic analysis and pull out the most salient topics. And this is incredibly powerful to be able to do this with so few lines of code. But when you do this, what do you end up with? And what you end up with is not kind of like 10 topics that are like whaling and Renaissance painting. You end up with a bunch of noise, right? Because what Wikipedia is supposed to do is not kind of cleanly represent all of these categories. It's an encyclopedia. It's supposed to cover everything. So it's got a lot of noise in it. So this actually is very powerful, but the corpus is sort of the problem here. It's not enough to drive the kind of application that you want to build, probably. So you need a custom corpus. You have to build it yourself. And that's really kind of one of the big lessons learned here. And so in order to actually teach people how to build natural language processing based applications, we had to really attack this from the beginning by building a way to make these custom corpora. Fortunately, because we know Python, that's not terribly hard. It only takes a few lines of code to go out and pull down an RSS feed and get the entries out and write them to files. Pretty easy, it's convenient. The problem is that when you're teaching a class, you need a lot of documents, and it sort of doesn't work to just do this the night before class and build a custom corpus that's big enough to really do anything interesting with the next day in class. So you need to start to anticipate things. So we started running into issues pretty quickly with ingestion, where we needed to be scheduling ingestion and planning in advance, and scheduling is a nice way to not have to remember because it's just going in the background. But we needed to be able to add new feeds because we want to build custom corpora, right? So as somebody introduces a new topic, we need to be able to add a new RSS feed so we can start gathering data about that topic. We need to synchronize feeds, find out where the duplicates are coming from, because that's going to tamper with modeling. And because RSS conveniently comes in a lot of different forms, we need to find some way to kind of unify those and standardize a little bit. And we need to monitor over time to see what's happening. And in terms of storage, quickly we can't sort of store all of this on my laptop or your laptop. So we have to pick some sort of database, and we started using MongoDB. So we have to think about how to represent the data and how to index and fetch data. We have to figure out how to connect and do configuration, how to identify errors and handle those errors. And we also need to come up with tools to export a corpus from the database so that you can pass it downstream to the rest of the processes to get it ready for machine learning. So, as the corpus starts to get big, right? We get, new problems come up all the time. So cost starts to become an issue as we have to get increasingly big EC2 instances to hold all of this data, and we get sort of surprising results from time to time. For instance, the time when we realized that there are all of these massive news article documents that had embedded videos in them. So that was causing an issue. So what started out as a few lines of RSS feed ingestion turned into this sort of production grade ingestion engine called Baleen, that has a lot of different components that handle these different issues that we encountered. And yet, even though we sort of have solved one problem, we have this whole new class of problems. Now that we have this raw corpus, we actually don't have usable data for machine learning yet. And so, what we need to do is have some way to transform the raw documents into things that we can machine learn on, which means we need to know, not just what words are in the corpus, we need to know how they're being used in context, because building in one context can mean something different than building in another context. They might not even be, noun, one might be a noun, one might be a verb. And so what we end up with is a list of, HTML documents, each of which is a list of paragraphs, each of which is a list of sentences, each of which is a list of token tag tuples. So we want to capture the tokens, the words, as well as the part of speech tags that tell us how those words are being used in context. As you might imagine, that processing step gets computationally intensive. And at some point, you want to be able to get sort of streaming access so that we can process chunks of the text at a time and not kind of do this all at once and crash everything. So we want a corpus reader that will let us kind of selectively pick chunks of the raw corpus for processing. We also want to be able to periodically store this post-processed corpus, this tokenized corpus, so that every time we run our machine learning models, we don't have to start from the very beginning, because that is annoying. And so what we end up with is, this list of tuples, and we still have to vectorize them, right? We need numerical vectors in order to do machine learning. But we have a lot of features. Language is extremely high dimensional, and that is a problem, particularly when you have a lot of text and you sort of don't know what the most informative features are for machine learning. And so you remember Yellowbrick, our machine learning visualization package. We started adding features to Yellowbrick that would make it easier to visualize text features to help support. So, looking at the top tokens within a text, maybe before and after stop words removal, looking at the distribution, even looking at how well our part of speech tagger is performing on our tokens. And then after that, we need some pipeline, right? So we need to be able to load the data, normalize the text, vectorize the text, do our feature transformation, and pass those feature vectors to our models in a pipeline and do it the same way every time, because this is going into an application. We don't want to have somebody have to push the button at each stage. And so what you end up with are these feature union pipelines, and this is all built into a companion project to Baleen called Minky. But now, how do we visualize the results? And so here we kind of introduced some, interesting applications of dynamic graph analysis that are part part of Minky. Minky does some graph extraction for us. It's important to sort of understand how big this corpus is. It's 1.5 million documents, 7,500 jobs, over 500 gigs uncompressed. So the key phrase graph, when you extract the graph of the key phrases from these texts, you get 2.7 million nodes, 47 million edges, and you've got an average degree of 35. And graphs here, end up being one of the only ways to really kind of get a snapshot of what's happening with the corpus, the key phrases over time. So just really quickly to go over the lessons learned here. If you want to build meaningfully literate data products, by which I mean, not just kind of experimentation on a toy corpus. If you want to build these kinds of things into your applications, you need a custom and domain-specific corpus. You also need a data management layer that allows for kind of flexible, iterative machine learning modeling. You want to be able to kind of experiment with feature analysis and algorithm selection, trying different algorithms. You want to be able to tune your hyperparameters, and you want to have the confidence of the data management layer that supports, iterating not at the kind of data management layer, but iterating at that kind of machine learning, the model selection layer. You need a custom corpus reader that's going to allow you to do streaming access to your corpus, and you need to plan for kind of intermediate storage of this post-process corpus, so you don't have to do the processing stage every time you want to fit a model. And you need tools for steering and for interpretation and analysis. So what we propose is graph analysis and using something like Yellowbrick to kind of help steer the modeling process to see kind of how the results are turning out. So, we kind of put all of these lessons learned together into a book. We did so my partners, Benjamin Bengfort and Tony Ojeda, who are my co-authors in this book, we did a book signing for the early release of the book with O'Reilly last night. And if you were there, you got a signed copy of the early release, which has the first half to 2/3 of the chapters. If you missed it, it's okay, because you can still buy those. You can buy the early release online, and as we push out new chapters, you'll get a ping that there's new chapters you can pull down. So we would love to have you check out the book and buy a copy. But of course, these are things that we made open source. So Baleen, the RSS ingestion engine, and Minky, the text processing and graph extraction tool library are available on GitHub, and we would love for you to check out those projects, fork them, submit issues, suggestions, or just tell us how you're using them so we can see kind of what you build with them. Yellowbrick, the machine learning visualization library, is also on GitHub, and we would be delighted to have you check that out and contribute, check out the issues, and see if there's anything that you wanna work on. We'll be here for the sprints, working on all of these projects, so you're welcome to come visit us during the sprints and see how you might contribute and hear more about what we're doing. We have a bunch of people from the District Data Labs team here doing all kinds of things. We had a great tutorial from Nicole Donnelly on the first tutorial day on getting data. So this is with data scraping rather than RSS ingestion. So two different sides of the data ingestion coin. And we'll have a poster by Benjamin Bengfort and Will Voorhees on data ingestion, which relates to the Baleen project on Sunday. Tony Ojeda is doing a talk on speed to insight with human-machine collaboration tomorrow. And we'll have a related poster on Sunday from Tony Ojeda and Sasan Bahadran. And then if you're interested in machine learning, we've got 2 posters related to machine learning. On Sunday, one on Yellow Brick, which is my pet project, so I hope you will come and check that one out and come visit me. And I have Yellow Brick stickers to give out. And also one by Benjamin Bengfort and Laura Lorenz on model management systems, which really is about how you kind of handle models as they grow and change over time. And as I said, we've got sprints going on multiple projects at the end of this week, and we have a PyCon District Data Labs page, so you can go and find links to all of these projects that I've mentioned, so it's sort of like a convenient one-stop shop, so you don't have to hunt around GitHub too much. So thanks very much. Again, my name's Rebecca, and you're welcome to find me on Twitter or GitHub. Most of my handles are Rebecca Bilbro, so at Rebecca on Twitter and GitHub and LinkedIn, so it should be pretty easy to find me. And hopefully we'll get to talk and see each other around during the rest of the conference. Thanks very much. So do we have time?
Oh, yeah, we have
like 5 to 10 minutes. So yeah, I think it's okay.
Okay,
People wanna
so
ask questions.
thanks everybody for coming. We can do 10 minutes of Q&A here. So please step up to the mics, and as always, please remember to phrase your question in the form of a question.
I have a twofold question. There are some techniques that have become more trending in NLP, like bidirectional LSTMs and word-to-vec and so on. And in those cases, it is not necessary to do things like parts of speech tagging and so on. So the question, 2 parts. What was the machine learning model, or what was the problem that you were trying to solve for which you want to build these corpuses? And the other one is, have you experimented with those other things that I mentioned, like bidirectional LSTMs, where you just feed tokens instead of tagging them and so on?
Yes. So I think that, really, there are a lot of models, which is, it's exciting. And I think, GenSim is an incredible, we all got really excited when GenSim started kind of growing really, really fast. It's incredibly, has a lot of utility. But I think in the end, all of this sort of still comes down to having a corpus where the words, where the language that's in that corpus is relevant to the application that you're building. And so it sort of, it doesn't really matter what model, if you're using TensorFlow, if you're using scikit-learn, if you're using GenSim, you still need a corpus that is relevant to the application.
But what was the application that you had in mind?
Oh, so one that I'm doing at work right now is I'm, looking at information about companies, so news articles about manufacturing companies, as a way to try to anticipate, the health of those companies, because they don't usually like to report it. So you have to sort of, you have to kind of find a way to intuit it. And so that's one application that I'm doing at work. Mm-hmm.
Hi, my question may be a bit similar to his, but were there insights about whales that you gleaned from that data set? Or features that you could speak to?
I will admit I don't personally study whales. Are you like a whaleologist?
No,
I don't know
no, but I have a project that's kind of similar to what you've been working on, and my goal is just to get insights from the corpus.
Okay.
And so it was kind of a what insights might you have found, and how might those have been different if you had not prepared the corpus as you did?
Oh, okay. So one thing I can say is that some of the data that we ingested for this kind of company, company information parsing experiment, a lot of the data we were getting turned out, so at some point the vendor who was selling this data switched from kind of very curated data where they were kind of hand-picking news articles to doing some kind of automated technique for curation. And at that point, our part of speech tagger went haywire, because all of a sudden, they were ingesting a bunch of new articles and doing automatic translation from Chinese into English. And our part of speech tagger didn't like that. So, but yeah, so in terms of, insights, you can use, these tools like LSA, LDA, or even like, k-means to kind of start looking for themes, and topics, and, kind of clusters of documents that, are similar. And a lot of times, in order to interpret those clusters, I kind of have to go to a domain expert, somebody who works in manufacturing, and say, what is this cluster? Because it doesn't, solid rocket motors doesn't really mean anything to me, but they'll say, oh, that's, the solid rocket motor industry. And so you kind of can work hand in hand with a domain expert, for example, to help label clusters, and then you can use that for classification.
Okay. I was kind of wondering if you did anything around multilingual speech ingestion or multilingual.
Not deliberately.
Or any no automated language detection at all?
No, although, that's, like I said, at some point we didn't realize that our data vendor had kind of shifted. So at work we actually purchase data. We ingest some ourselves, but we actually, purchase data. And at some point, it switched to being, things that had been automatically translated, like machine translated from Chinese into English. And, it does maybe a fairly good job if you're a human and you're kind of trying to get the general sense of what an article was about. But our part of speech tagger is just regular expressions and sort of expecting some degree of regularity, which kind of started to fail very quickly when they adopted this new strategy. So that's maybe not that like kind of happy story that you were hoping for, but yeah, you come chat with us at the poster session. We can maybe tell you some better stories of when it's worked a little bit better.
So I'm curious how much of this under the hood you are rolling your own, and how much of it is, an interface to Spacey or NLTK or any of those. Have you done a lot of algorithm development in this?
So we leverage, mostly open source implementations. So for Minky, Minky uses, some GenSim, like the GenSim TF-IDF is really nice. So there's no need to like write my own crappy one when there's like a really awesome one that's not, already there and available to me. So.
Hi, thank you for a great talk. I was wondering, so there is a lot of effort that goes into building this corpus, right? You have to bite the bullet. Like you start off with a small project and you think that you get started with a small corpus. Most of the techniques that you highlighted here were about unsupervised learning. One of the things with the great corpuses is that they come with those tagging done by humans. What do you feel about that, or what's your experience regarding a new corpus?
So you're asking about kind of classification tasks?
Yeah, sure.
Yeah. So one of the things, so we got one of these slides. It's the yellow brick slide. So this graph on the right-hand side is a stochastic neighbor embedding visualization of the Bayesian corpus. And the colors here indicate different categories of documents. And there's a key on the right-hand side, but it's tiny and you won't be able to see it. But we're circulating the slide so you can check it out and inspect it a little bit. But basically what this does is it shows you on a category basis how distributed the documents are when you do this kind of projection. And so this can kind of even tell you, like, am I going to be able to do classification? Like, do you see separability? When you look, so maybe some of the documents, right? But some of them, like this gray one that's kind of like smooshed all over everything, maybe pull that out and see if you can get some like nice, more cohesive clusters before, so, but basically, classification sort of depends on separability. So this is, one way to visually explore that. Does that answer your question?
Partly, I was more wondering about, like, when you're building a corpus, do you also, most of the corpuses historically that we have used are human tagged. So did you ever consider using, mechanical Turks for classifying your text, which you were pulling like raw from these places.
Yeah, I think, yeah, so MechTurk I think is a great resource, and it's cheap, but also like people sort of game the system a little bit. So even with MechTurk, it's hard to get consensus for categorization. So you have to collect a lot of feedback. But yeah, it's a great technique, and like I said, like using domain experts, like at work when I engage with domain experts to help me categorize things or classify things, there's really nothing that beats somebody who really knows the domain coming in and sort of telling you what you're looking at.
Thank you.
Yep, sure.
We got time for one real quick one.
How do you know that you're on track, especially in the early stages of a project where you have a whole lot of data coming in and maybe you don't know it very well or it's not your primary language? How do you sort of check that you're on the right course?
So on the right course in terms of like, am I actually collecting a domain-specific corpus?
Before you invest hours and hundreds of thousands of dollars.
Actually, that's a really great question. And what I would suggest is using something like this kind of periodically over time and sort of looking at how it changes over time. And if you're getting kind of like blah, early on and it stays kind of blah, maybe point your ingester as something else. But probably what you'll see is like certain certain key phrases will get big and maybe stay big, and other ones will get big and then they'll shrink. And so what you're kind of looking for is signal, right? And you can kind of visually identify that quickly with something like a graph.
Thanks.
All right. Thank you very much, Rebecca. Thanks, everybody, for coming. Have a great day.
For text processing. But then I'm going to tell you all the stuff that could go wrong if you do, just to kind of measure your expectations a little bit. So the kinds of things that will likely go wrong kind of from the beginning, the data ingestion phase, all the way through management and loading, preprocessing, and analysis. Then I will talk about some of the lessons that we learned. Hopefully you can learn from our mistakes and not make the same mistakes, make new mistakes. And also kind of introduce some of the open source tools that we built to make this work easier in the hopes that you will be able to leverage those tools yourself. First off, my name is Rebecca Bilbro. I am
Ready for coming. Our next speaker is Rebecca Bilbro with Building a Gigaword Corpus, Lessons on Data Ingestion, Management, and Processing for NLP. Please give Rebecca a warm PyCon welcome.
Hello. Welcome to my talk on building a Gigaword Corpus for NLP. So I'd like to begin by talking a little bit about my motivation for building such a large custom corpus and for giving this talk. And I want to try to convince you also that you would like to build a custom corpus. A data scientist. I live in Washington, D.C. I work for a company called Bytecubed that builds custom data solutions for commercial and government clients. But in my free time, I work on open source projects like Yellowbrick, which is a new open source Python library for visualizing machine learning model selection to support the modeling process. So it's pure Python, it uses matplotlib, and it's sort of modeled on the scikit-learn API, if you're familiar with that. So I do this work with a team called District Data Labs, some of which is here with me. And many of us are here at the conference, so you're likely to bump into some of us. So District Data Labs is a Washington, D.C. based open source collaborative. So it's a group of people who have day jobs but enjoy open source and programming and get together in their free time to build projects. And we try to support that by hosting research labs and development sprints and supplying things like pizza and water to encourage people from the community to come and develop with us. And we pay for those things by teaching classes in things like machine learning, natural language processing, data wrangling, distributed computing. And there has been recently quite a lot of interest in classes on natural language processing. And so this is kind of how this journey begins. There is a dramatic increase in recently in applications that are integrating sort of seamlessly and quietly, these innovative natural language processing features that extend the usability for all of us. So for instance, Gmail just released a new feature, probably some of you have noticed it, where it kind of scans through your incoming email and suggests, convenient, quick responses, so you don't have to type out, like, sounds great, see you tomorrow. So this is sort of kind of happening in mass, and at the same time, there's this, flood of great tools in Python